All right, we're on page 5. We did not, I don't think we got to any of the problems on this page yesterday, right? Okay, so here's what I want you to do. Try to answer these 2 questions and these 3 here that refer to this picture. So based on what we did yesterday, see if you can answer those 5 questions, and then we'll talk about it. If you need to go back and look at your notes, you can do that. See what you can come up with. So we had a lot of terminology yesterday, right? A lot of kind of new words, new vocab. Trying to figure out how it all works together. That's going to be kind of our goal today is talking about lines and planes and all of these things, intersections of those things. So what I would tell you is try, when you have statements, and we're going to see this on the activity that we do, break the statements down into like smaller parts. Take it like one little thing at a time, kind of like you would do with like a story problem, okay? Where you try to like break it down into small parts, maybe look for keywords, things like that. But anyway, on this one here, which sketch shows 2 different lines? So that's where we're going to say, okay, 2 different lines that intersect a plane at the same point, okay? So this one here, does this one have 2 different lines?
Yes.
Absolutely. Do those 2 lines intersect?
No.
Okay, so we do have 2 lines. Those 2 lines do not intersect. So number 1 is out. Okay. Do we have 2 lines here?
Yeah.
Yes. Do those 2 lines intersect the plane at a point?
Yeah.
Yes. Okay. That point is on the plane. They intersect the plane. Okay. So that one is definitely good. But what we talked on some problems is make sure there's not more than one that possibly work. Okay. We know that one does. Okay. I think this one's kind of tricky, maybe kind of cheap. I would say sometimes when we see questions like this. Okay. What kind of figure do we have right here?
Array.
It's array. Okay. Starts at A and goes through B. Okay. So it's not really a line. It's a ray. And then this one here is a line. So do the ray and the line intersect? Yep. Okay. Do they make a plane? Yeah. But here's where it gets a little bit dirty is that this is a ray and we don't really have 2 lines. We have a ray and a line. And so that's where it gets a little bit tricky is that yes, they intersect, yes, they make a plane, but it's not 2 lines. Okay. If this would continue on a little bit further, then it would be 2 lines that intersect at point A, and those 2 lines would end up making a plane. If I were to draw 2 lines up here, do these 2 lines intersect at a point?
Mm-hmm.
Absolutely. Do those 2 lines intersect at a point on a plane?
No.
What would be my plane here?
Would it be the point?
It would be the surface that we do the lines on, right? The board would be our plane, right? So the 2 lines intersect at a point, and they're part of the same plane.
Oh.
Okay,
Oh, I
so-
understand.
Yeah, it's kind of weird, right? It doesn't have to be like something that we're holding out there, okay? The plane, like we said yesterday, it could be a wall, it could be a ceiling, it could be a floor. Your plane could be a lot of different things. I use that piece of paper as an example sometimes. What's that?
So it's not the little papers that are on
Right.
these. It doesn't like, okay, I understand.
Yeah. Okay, so number 3 was out. Number 4 only has 1 line, so that one definitely is out because we need 2 lines, and it's only the second one. Okay, and this one here, 2 planes that do not intersect. So the 2 planes cannot touch one another. We think about what intersect means. If 2 lines intersect, they intersect at a point. That means they're touching one another at that point. So we need 2 planes, 2 flat surfaces, kind of like the ceiling and the floor. Those would be 2 parallel planes, 2 planes that never intersect one another. Okay, these 2 intersect each other at the line, the edge where they're touching, kind of like the Kleenex box that we said yesterday. These 2 intersect where the 2 meet, right there in the middle, where they make that X. This would be the top, and this would be the edge where these 2 planes intersect. They're touching right along this edge right here. These 2 planes never touch one another, okay? And they're one's right on top of the other one. They never touch one another. So this would be the one that we want. Okay, this one here is 2 planes intersecting. When I name this figure right here, what would we call that figure? It'd be line PQ, okay? So line PQ. That's one of the things that I really want you guys to get out of this first section is how to name and what are the names of all these, and then what are the symbols that go along with it, because all of these symbols are a little bit different and they all mean something a little bit different. So we read this as line PQ, okay? This is line K. Line PQ starts at P, goes through Q, so it's talking about this line right here. It's the line that P and Q are both on. Line K is talking about this edge or this line right here. Here's the difference. P and Q are points. There is no lowercase letter out to the side. Sometimes we use points on the line to name it. Sometimes we use a lowercase letter out kind of to the side or by that line. This one is my lowercase letter. K is not a point. K is just a lowercase letter used to name that line. So those are my 2 lines, okay? Where do line PQ and line K intersect? Well, we talked about this yesterday. Where do 2 lines intersect?
The middle.
Okay, which would be what? What do you think?
The point.
Okay, which point?
Wait, what do you mean?
Where
Point
do
K,
the...
point K, point K.
Okay, but K is a line.
Oh, yes.
Okay, so here's line K. Where would line K intersect line PQ?
Middle, yeah.
At point
And
M.
M.
Yeah,
Oh,
yeah.
I thought the M was to
Wait.
the.
Oh, that's okay, I didn't know. I
Sure.
haven't
Yeah.
May I use the restroom?
Yeah.
Thank you.
Okay, so here's line K. Here's line PQ. And then M is that point right there in the middle.
M is the point.
Yeah.
I didn't notice.
Yeah, since we have a point here, points are always named by a capital letter, okay? And so that is the point closest to M. Or M is the letter closest to that point, however you want to look at it. Okay? So the next one says, name the intersection of plane A and plane B. Where do 2 planes intersect? A line, okay? So we need to answer this with a line. 2 planes intersect at a line. So plane A is the one that's going left to right here, okay? If you, I don't know, I can shade it in. It would be this line right here, or this plane right here, okay? Plane B would be this plane right here, okay? Just to kind of shade it to kind of see the difference between the 2. Where do those 2 intersect one another? Line K. Okay, K is the line that both of those planes share. When I name that, we aren't using a point, we're using a lowercase letter. So we have to say line K. We can't just say K. Here, I could say M because if it's a single uppercase letter, it's assumed to be a point. Okay? If I say line K, or if I say little k, we don't really know what we're talking about because K is not a point. K is just a letter naming that line, so I say line K. The intersection of line K and plane A. Kind of a tricky one. Where does line K lie? Yeah, what do you think? Okay, M is in there. Okay, they definitely have M in common.
The middle.
Okay, and so here's how I think of this one. If I had a piece of paper and I lay a line right on top of that piece of paper, okay, where are the piece of paper, the plane, and the line intersecting at?
Right where you're laying the pencil.
Right where I'm laying the pencil at, the line, right? My pencil is my line here, okay? So the line and the pen and the paper, the plane, have this line in common. I'm just laying the line right on top of it, okay? So this entire line is intersecting that entire plane, okay? And there is many points on it. M would be one of those points, but there'd be multiple points, and so it would be line K. And that's where that one is kind of tricky. Because line K lies right on top of plane A. Okay, this is kind of a weird looking picture. We got what we call a sulfur hexafluoride molecule. It's going every which direction. It goes up and down, left and right, front to back, kind of a three-dimensional molecule here. I want to name two different planes that contain line R. Okay, so line R is this plane right here, or line right here. Okay, it has multiple points that lie on it. It has D, it has B, and it has F. Okay. So first of all, when I name a plane that contains line R, I need to use 2 out of those 3 points. I can't use all 3 because then they would be collinear and they would not be on the same plane. So I'm going to pick 2 of them. Okay? And probably, I mean, there's a lot of different ways you could go here. I could say DBA. Is a triangle a plane?
Yeah.
Yeah, because we have 3 non-collinear points, okay? So I could say DBA. Does it matter what order I put those letters in? No. Okay, so I could flip these around in any order I wanted to. I could go ABD, BAD. Once again, we got to pick 2 from that line, 2 points, and then a third one somewhere else. Okay, so what would be another one? Okay, ADF, ABF. Okay, yeah, ABF. That would be a good one. Okay, BFC. Yep, that would be good. We could go DBG. There's all kinds, okay? And we could name a lot of those a lot of different ways. So do I have a ton of possibilities here?
Yeah.
Yeah.
It's got some.
It's got so many different things, and it's going in so many different directions. I could name all kinds of different planes. But the key is, we got to pick 2 off of this line. We can't use all 3, because then it would be a line, and it would be collinear, and we don't want it to be collinear. So if I pick 2 here, and then another one that goes in any direction, we would be good. Okay, so something like that on a quiz or test would be really hard for me to grade because there's so many possibilities that it could be.